In this video, we're going to learn how we can simplify a fraction. To do that, we're going to identify factors of numerators and denominators. We're going to divide those by a factor. And we're also going to have a strategy for simplifying big numbers that maybe we don't know the factors for. We're going to look at two examples, and then there are going to be some suggested practice problems at the end for you. So the first example that we're going to look at is just 5/10. Now, if you look up at the top, there is a visual model of what 5/10 looks like. We have 1, 2, 3, 4, 5 out of 10 shaded in. Now, you may also look at that and say, well, that looks like it's half. That's because it is. An equivalent fraction to 5/10 would be 1/2. Now, it works well if you can see it visually, but in terms of doing mathematically, we have to do a little bit something else. What we're going to do is we're going to look at either the numerator or the denominator. I would pick whichever one is smaller, and think about what can we write as factors for it. So if you don't remember a factor, it's just two numbers that multiply together to give you that number. So if we look at 5, we know that 1 times 5 works, and that's really about it. Those are the only two factors for 1 and 5. That's because 5 is a prime number. 10 and 5, for 10, we actually have a few more. We can, of course, do 1 and 10. We can also do 2 and 5. Both of these will give us a value of 10. And you'll notice that in both numbers, we have a factor of 5. If you are listing your factors and you find a number that is a factor of both your numerator and denominator, that is the number that you want to pay attention to. What we're going to do is we're going to take those factors and divide our numerator and denominator by that value. Now you might be thinking, Mr. H, isn't that going to change our numbers entirely? Well, no, not really. Because what we're actually doing is we're dividing this by 5 over 5. 5 over 5 is just one whole. But we can use that to at least make this look a little bit nicer. So if we have 5 divided by 5, that's going to give us 1. 10 divided by 5 is going to give us 2. So we do indeed end up with 1/2. That is exactly what the model is showing us. As we discussed earlier, not too bad. You just need to list out factors. So what happens if you have two really big numbers in your fraction? I personally don't know, for example, in this example, all of the factors for 128 and 256, and I suspect it's going to take an awfully long time to actually find them all. So instead, what you can do is you can use smaller numbers that you can use more easily. For example, if both your numerator and denominator are even numbers, we can just divide these both by 2. Now you might have to do some long division to figure out what 128 divided by 2 actually is. I happen to know that it's 64, so we're not going to go through all that process, but you may have to do that in order to simplify a little bit. So, if we divide by 2, we're going to get 64 as our numerator, we're going to get 128 as our denominator, and again, I don't know all the things that multiply together to give us these numbers, but I notice that they're both even numbers again, so I can divide by 2 again to get 32 and 64. Now at this point, I actually do know some numbers that we could use. If we list out all of the factors of 32, we could have 1 and 32, of course. We could have 2 and 16. We could have 4 and 8. And, well, that's actually it. If we do the same thing for 64, there are actually going to be a few more factors, but the one that we really care about in this case is going to be 8. times 8. And we'll notice, just kind of like we did in the previous example, we have an 8 here and an 8 here. So that means we can divide both of these by 8. There we go. And really, whatever the other number is, that is going to tell you what that's equal to. So we're going to have 4 over 8. Well, I know that 4 over 8 is the same thing as 1/2. So we again have a fraction that's actually equivalent to 1/2. It took a few more steps to simplify, but it's not too bad. Sometimes you won't be able to simplify something, and that's okay. Check to see if there are any factors it has in common. Sometimes it won't. That's especially true if there is a prime number in your fraction. It's still possible to simplify them, but the only thing you'd be able to simplify it by is that prime number. So hopefully that helps with some of the ideas of simplifying fractions. We're going to leave you with a couple of practice problems here. The first two, the two on top, you can do just by listing out factors for 16, 36, 27, and 36 again. The second one is going to be a little bit harder. Think about some of the patterns that we talked about in example 2. I'm willing to bet, though, that you can find a bigger number than just 2 to try to divide this by. But I'll let you think about it. Good luck.